In the standard 8.EE.8a, we are asked to understand that solutions to a system of two linear equations in two variables, like the example that we have here, correspond to points of intersections of their graphs because points of intersection satisfy both equations simultaneously. So in this particular system, notice that we have identical equations, y equals negative, or y equals 7x plus 6 and y equals 7x plus 6. If we were to think about what their graphs look like, we can just sort of think about, well, we know that y equals 7x plus 6, 1, 2, 3, 4, 5, 6. We have a y-intercept of 6 and a slope of 7. So this thing ends up going uphill from left to right. Clearly has a y-intercept of 6 and a slope of 7. And then if we were to graph the second equation, clearly it's the same exact equation. So that means its graph would lie directly on top of the other one. Sometimes that's stated as coinciding. So as far as what the graph looks like, well, we can see that it would be this situation right here. The graph of the system consists of lines that have more than one point of intersection. In fact, every point on those lines intersect each other. And in other words, an infinite number of times. Now, as far as what the solution is, we always know that means we have an infinite number of solutions, so more than one solution. So what would it look like if we change the problem slightly? So for example, what if we made a slight change and this one was y equals negative 7x plus 6. So that would mean if we were to graph this system, and there is 6, so the first equation might look something like this. We know it's going to go through positive 6 on the y-axis because that's the y-intercept, but it's going to have a negative slope. And I'm just sketching this, so a little sloppy here. But then the other one also goes through positive 6 on the y-axis, but this one has a positive 7 as a slope. So it might look something like this. Now, as far as what the graph looks like, well, clearly there is exactly one point of intersection, which means that we have exactly one solution. Now, one other scenario that might appear here is what if instead of what we have, what if now one of the y-intercepts is slightly different? So they have the same slope but different y-intercepts. So if we were to do a quick sketch, the first equation has a y-intercept of positive 6, has a slope of 7, but I'm just kind of sketching that. The second equation has a y-intercept of 4. It has the same exact slope. So what that means is we end up with parallel lines since both of those lines rise 7 and run 1, but they just go through different points on the y-axis. So as far as what this graph looks like, there are no points of intersection. And as far as what the system has in terms of a solution, it has no solution since those two lines never cross each other. In the standard 8.EE.8a, where we're asked to understand that solutions to a system of two linear equations in two variables correspond to the points of intersections of the graphs, we may be presented with a problem like this, where we are given the graph of one equation in a system of equations, and we're supposed to write a second equation that has no solutions? Well, the only way that we can go about this is if we actually state what the equation is of the graph that is already plotted for us. So we can see in this particular graph that we have a y-intercept of -3, and we have a slope. So now I got to locate a couple of perfect ordered pairs, and it looks like there's another one right there. So we are rising 7 and we are running 4 to the right, so that means we have a positive 7/4 for the slope. So this is the equation of that line right there. So now we're supposed to write a second equation in this system so that we have no solutions. Well, remember that when we have a graphed system that has no solutions, we end up with parallel lines. And I just quickly sketched that. But let's pretend like I got a little more accurate there. Let me take that off and try this again. And that's a little bit better right there. So that would mean that the slope has to be exactly the same, but we need different y-intercepts. So maybe -1 right there. So y equals 7/4 x minus 1 and y equals 7/4 x minus 3. Graphically, they are parallel lines that have different y-intercepts. But if we were asked for the actual solution to that system, there would be no solutions. If we were asked for instead infinitely many solutions right there, well, then that would mean we would need these two graphs to be identical to each other. So they would have to be exactly the same line. So in a situation like that, they would have to be identical lines. So just be aware of that if you happen to see a problem like this. In the standard 8.EE.8a, where we are asked to understand that solutions to a system of two linear equations in two variables correspond to their points of intersections on their graph, we may be presented with a problem like this one, where we are asked to use the line tool down at the bottom to graph any system of two equations that has a specific single solution. In other words, that would be where the two lines would be crossing each other at the same time. So in my opinion, a problem like this is easiest to kind of start by graphing one equation at that solution. So at 5, -3. 5, -3 is right there. So I'm just going to create any equation that happens to go through that point. Now, as far as I graphed in a line of an equation that goes through that point. Now, as far as the second one, it also has to go through that point. So maybe like that. And so basically we have satisfied what we were supposed to do there. We use the line tool to graph any system of two equations. I did that. And they happen to cross each other at 5, -3. So therefore, that has to be the solution to that system of equations.